Hello guys, welcome back to Med Zone African Motives. Still working on Mechanotechnics and 5 revisions. In this case, we shall be focusing on the elevators. That is the question paper of April 2023. So that is 10 marks for everything. As we can see, this question that is consisting 10 marks. So we shall try by all means to see what exactly we are given and how are we supposed to answer such typical questions. Okay, in this case, we are given that the weight, we are given the weight in this case of a loaded drug. So, okay, I'm going to take this stage by stage. Sorry for that. All right, I'm going to take this stage by stage. The weight of a loaded cage of goods elevator, we are dealing with a goods elevator, is 1,600 kgs. So this is the weight of the loaded cage of goods. We're talking about the load in this case. That is, we are talking about the mass of the load at a particular point. It is traveling at a speed of 1.65 meters per second and accelerating at 0.95 meters per square second. So what is actually happening is that the hoisting drum that the rope passes over is a radius. So meaning to say, this load that we are seeing, it is going to pass through a drum. So here we are going to have a drum. So we are going to carry this. It is going to be like this. All right. So we're just going to have something of this nature along our drum. All right, something I just hope. All right, let me just make it nice a little bit. Okay, so this is across a drum. Okay, it's gonna pass through a drum. So in this case, we are talking about the load, and it is going to be balanced by a certain mass in this case, which means we are going to have a certain mass here. So this one is the first mass that you are having, which is the load that you are given, the weight, but you are given the mass of it in this case. So you can just refer to M1, which is 1,600 kgs. This is the mass of the load. This is where you have your load in this case. All right. So this load is going to be going upwards. All right. So we are going to definitely have a tension or a force that is going to be experienced up due to acceleration across this drum, and here it is going to be going down, whereby we shall have a mass that is going to balance up this load that we are having. So here we shall need a mass that is going to balance up this load. All right, so that is what we have. So at a particular point, we are given that it is traveling at a speed of, we are given the velocity in meters per second. This is linear velocity. If it is rad per second, it is a angular velocity, but here meters per second, we are given the linear velocity of 1.65 meters per second, and the acceleration in this case, which is of 0.95 meters per square second. The hoisting drum, which is this one that we have, that the rope passes over, has a radius of gyration, which is 450 millimeters. So this radius of gyration is affecting the drum. So I'm just going to list the information of the drum here. We are given the radius of gyration, which is given as K. It's not R. This one, the radius of gyration, this one is given as a K. So that is 450 millimeters, which you convert to meters, divide by 1,000, you're going to have 0.45 meters. All right. A mass of, so this is affecting all the drum. Take note, the hoisting drum, this is the information about the drum. So this drum that we see, it has a mass. This is the mass of the drum, which is 350 kilograms, and a radius. Now we are talking about the radius of the drum from the center to the point whereby we're now talking about the real radius of the drum, that is 0.45 meters. So we've got the radius of gyration, and we've got the radius, the actual radius, okay? Then the frictional resistance between the cage and the shaft. Take note, we're talking about between the cage and the shaft. The cage is which part? A loaded cage of goods. So meaning to say, this part here is where we are having a loaded cage. So this frictional resistance, it's affecting the load in this case, which is the load. So let me just put it this way so that we do not confuse. There is information about the load, which is the loaded cage. So on the load, that is where we are given a frictional resistance of 670 newtons. So we've got a frictional resistance here of 670 newton. and the frictional resistance of the counterweight and the shaft. The counterweight and the shaft, which is this one that is balancing, the one that is there to balance. A counterweight of is, take note here, they are even explaining that a counterweight of mass is used to balance the elevator. So we are talking about this, the balance, in this case, the support balance, this one. This is our support, all right? So here we're talking about the support balance. This will be our support balance in this case. So on the support balance, we've got a frictional resistance that is affecting there. So we are going to be talking about the support balance in this case, that is we've got its frictional resistance on the support balance. The frictional resistance on the support balance is given as what? 460 newtons. So we've got 460. Sometimes they might give us the same frictional resistance affecting the load and affecting the support balance. But in this case, we are given two different. All right. So take note about your information. All right. That is also on this balance, we are given its weight, which is 850. So this is the mass of the balance of 850 kgs. And also we are given the frictional torque on the drum. We are now talking about the drum in this case. Remember, this is the information of the drum. So the frictional torque on the drum is given as 290 Newton meter. So that is our information, the whole information about the question. And the question is calculate the total torque required, the total torque. All right. Let us analyze, guys. This is our whole information about the elevator, the goods cage that is being loaded up with goods in this case, and having a support balance of mass 850 kgs. What is supposed to be the actual torque in this case? All right, the actual torque which is the total torque in this case, let me put it this way. The total torque is supposed to be taken from the torque that is affecting the drum. All right, we are going to be talking about the drum on itself, which is, we can just write it as T rope, the one that is affecting the drum, plus the one that is affecting the load. So we are going to have the torque that is affecting the load in this case, and this one is from the drum in this case, and this one is from the load to accelerate the load. This one is to accelerate the load, the load in this case. So meaning to say, we are going to need these two, the torque for the drum and the torque for the load. So how are we going to obtain the torque for the drum in this case? All right, that is the question. All right, so let us put it this way. I'm just going to have these calculations aside separately. So the torque in this case, let us just have the information on the torque to accelerate the drum, torque to accelerate, all right, accelerate the drum, to accelerate the drum. All right, let me just try to reduce a little bit. All right, to accelerate the drum in this case. All right, so what is going to be the torque in this case to accelerate the drum? That is the one that I wrote here as T rope. So T rope is given by the formula, or the torque to accelerate the drum is given by the moment of inertia times the angular acceleration plus the torque that is against resistance in this case, which is the one that you are given of the drum. If you are not given, then it's fine. But here, take note, we are given the frictional torque on the drum. So meaning to say we are going to work with the frictional torque on the drum. So this is the formula that you are supposed to use. But if you take note here, we do not have inertia. We do not have the angular acceleration. So what are we going to do? For the inertia, it follows that the formula for inertia is given as mk squared. So inertia is given as mk squared, which is, now we are talking about the radius of gyration that we had in this case here, and also the angular acceleration. Remember from your engineering science N3 N4, we talked about the conversion from the one that is in angular to linear. So we want to change this to linear. So it follows that angular acceleration is equal to the acceleration over the radius. All right. So if you are given anything in linear, if you divide anything in linear, you get angular. Let's say we want angular velocity, it is going to be velocity in linear over radius. If we want theta, it is going to be S over R. So that is the whole concept of converting from linear to angular. You just have to divide that part in linear by the radius. You obtain what? The angular part. So meaning to say, we have acceleration here. If we check the radius, we have the radius of the drum. So meaning to say, we can use this part in place of what? The angular acceleration. We also have the mass of the drum and the radius of gyration. So meaning to say, we are going to substitute these to give us the actual part in terms of what we are given. So like the moment of inertia, we said this is going to be mk squared multiplied to the angular acceleration in linear form. It is going to be the acceleration over the radius. So this is what we are going to have, plus the frictional torque in this case. All right, so that means we can have our answer for the torque that is affecting the drum. We have everything in this case, the mass of the drum, which is, we use the mass, we are talking about the drum in this case, so we use the mass of the drum, which is 350. So it is going to be 350 times k squared in meters, 0.45 squared in meters, times the linear acceleration now, because we do not have this angular, so we're going to use the linear acceleration over the radius, which is the linear acceleration of 0.95 over the radius of the drum in meters, that is 0.45. All right, so that means here we are going to add the frictional torque in this case of 290. That is the frictional torque here. So this part here, this whole part is a single term. So we are going to combine everything. We are going to combine everything in this case. But the first part is going to give us 149,625, something like that, plus 290. So if we add these two, we are going to obtain 439,625 Newton meter. So this is our torque that is affecting the drum, which is T-Rope in this case. All right. Now we have to ask ourselves to say, what about the one that is affecting the load? Because we have this one now. We are left with the one that is affecting the load in this case. All right, so let me bring it on top so that we can calculate this one aside. Let us just calculate the one that is affecting the load in this case. So it follows that the torque that is going to affect the load, all right, is going to be from the tensions that are these two, because as the load is going up, it is being supported. There's a balance, which is the support balance. So it is affecting. So it is going to be T1 minus T2 times the radius. So I'm simply saying here, all right, or we can just write it this side here. Okay, let us have it this way. This side, I think it can help us. We just need the diagram. All right, so I'm simply saying the torque that is going to be from the load to the one to accelerate the load. So this is our T load in this case. That is the torque to accelerate the load. To accelerate the load in this case. All right. So T load is simply taken from the formula. You are going to use this formula T1 minus T2 times the radius of the drum in this case. But if we check, we do not have T1, we do not have T2. So T1 is due to acceleration as we are going up. T2 again due to acceleration as we are going down. So what is going to be the formula for T1 and T2? All right, so let us calculate our T1 and T2 aside here. So we are going to calculate T1. This is due to acceleration. So T1, that is the one that is going up. So the formula for T1 is going to be M1 into gravitational acceleration plus the acceleration. Then you add the frictional resistance in this case, all right? If it is going up, T1 is going up. So you just have everything is under positive so that you do not confuse, all right? Anything going up is going to be positive. Sometimes you might have a negative acceleration. That is where you put a negative acceleration, but it's supposed to be positive up. It's going up, T1 is going up. And you also use the mass of this T1, the mass that is affecting T1 is M1, the mass of the load, this one, 1,600 kgs. So that is the whole part. So in this case, we are not given the gravitational acceleration. Sometimes they give you the gravitational acceleration. So we're not given, use 9.81 meters per square second. That is the gravitational acceleration. In this case, we are going to use 9.81. All right, so that is the formula for T1, which is the one that is going up. So we have the values. We are simply going to substitute in this case. So T1 is going to be M1. That is the mass of the load in this case here. M1 is 1,600. All right, so we are going to have 1,600 in this case. This is going to be 1,600 into the gravitational acceleration of 9.81. You are not given, plus the acceleration. Acceleration, this one is a positive because it's accelerating. If it is decelerating, you're going to take it as a negative. So this is a positive 0.95. All right, so you're going to add 0.95. Then here, be careful. Remember, I talked about these two frictional resistances that we have. We are talking about the frictional resistance that is affecting the load, the one that is going up, because here we are given two frictional resistance, the one for the load, as I explained, and the one for the support balance. So we are calculating T1, which is affecting the load. So we are going to use the frictional resistance that is affecting the load, which is 670. We are given different frictional resistances. So we are going to use 670 in this case, all right? So that is going to be 670. So that's it. We are going to obtain T1 in this case, which is going to give us 17,886. That is the tension that is going up. So in this case, we are talking about the force in newtons in this case, all right? So here we talk about the tension, which is the force. Take note what we are talking about here. So this is the force which is measured in what? In newtons. Now we talk about T2, which is going down. So T2 is the one that is going down. So T2, we are simply going to use the same part, but T2, as we can note, it's now affected. This tension is affected by M2, which is the support balance, and it's going down. So we are going to use negative on your formula. This one, we are going to subtract. I think if you take from engineering science N3, we talked about this. So this is going to be M2 into G minus A minus the frictional force. So that is the whole concept. So meaning to say we can calculate T2, the mass of 2, which is the support balance. In this case here, the support balance is 850. So we are going to use 850 kgs. Be very careful about the masses that you are going to use. So this one, we are going to use M2, which is 850 into G, 9.81, minus the acceleration. Remember, our acceleration is 0.95. And this time we are given different frictional resistances. So we are supposed to use the frictional resistance that is affecting the load balance in this case. And the one that is affecting the load balance here, the support balance, I mean, is 406. So we are going to subtract 460 in this case. So that is the whole concept. So this one, we are going to subtract 460. We obtain T2 from this way, which is going to be 7,071 in Newton. So that is our tension. So now with these two tensions that we obtain, T1 and T2, we are going to use them to calculate the torque to accelerate the load, which we said T load is going to be taken from T1 minus T2. So T load is T1 minus T2 times the radius, which is T1, which is 17,886 in this case, minus T2, that is 7,701. So we multiply to the radius in this case. So we are going to go back in this case to the radius that we are given, and our radius according to our information is what? 0.45. This is the radius of the drum that we have. So we're going to multiply by 0.45. All right, so that's times 0.45. So that's it. We have got the torque that is affecting the load in this case, and this is going. So take note, I'm using T on this other side for torque. I'm using T on the other side to represent the load, to represent whereby we talk about tension in this case, which is the force. So do not confuse. When you're talking about T1 going up, T2 going down, these are loads. We're talking about, these are forces, tension, mass times gravitational acceleration. That one is just a force. But this T, I'm representing to the torque in this case. So maybe we could just use F1, F2. But according to your syllabus and presentation, they just use T. But do not confuse between this T for the tension and the T for the torque in this case. All right. So here we are going to obtain the torque that is affecting the load of if we simplify, that is going to be 4,866.75 Newton meter. So now we are talking about the torque affecting the load. All right. So the question was to calculate the total torque, and I said from our formula here, the total torque is simply the sum of the two, which is the T rope and the T load. The T rope is the one for the drum, the one that to accelerate the drum that we talked about here. We talked about the torque to accelerate the drum. And we also talk about the torque to accelerate the load from T1 minus T2 times, whereby you have to calculate T1, you calculate T2, find them. Now we can calculate the total torque because we said the T total in this case is going to be T rope, the one for the drum. From the drum, we obtained a torque of what? 439. This is 400 of, all right, that is 439, okay, comma 625 plus the one for the load, in this case, T load, in this case, we got 4,866.75 Newton meters. So we are going to obtain the total torque in this case, which is going to be 5,306.375 in Newton meter. So that is the whole concept of the question. Sometimes they do ask this question in as different part. They ask you to calculate the tension, that is the one that is going up, T1, the force going up, force going down. They ask you to calculate the torque for the load. They ask you to calculate the torque for the drum. And now they ask you to calculate the total torque. You are supposed to be careful. This one, they just ask this as a single question, calculate the total torque, but the stages that you are supposed to take are not going to change. You are still going to follow those stages as they are. All right. So you can start by calculating the torque that is affecting the load. In this case, that is the torque to accelerate the load, or you can start with the one for the drum. It's up to you. But be careful also, like I said, if it is an acceleration, you are going to use this as a positive. If it is a deceleration, it means our A is going to be taken as a negative. So this formula here is going to be affected as a negative. Here it is going to be a positive when it is a deceleration. So this is what we just need on elevators. This is all you need. You just have to work with more questions so that you see how do they ask these questions and how are you supposed to attempt these typical questions. I think with this information, we can answer as much questions as we can.